Hi, this is a lesson that is going to discuss residuals, residual plots, outliers relative to a scatter plot, and interpolation and extrapolation. So kind of a lot. Make sure that you're all set by having your graphing calculator handy and something to write with to take your notes, and let's get to it. All right, so a residual, this is the definition. It is the difference, so you're subtracting. When I say difference, that's subtraction. It is the difference between your observed y value and your predicted y value. So the observed y value comes from your scatter plot, whereas your predicted y value, that is from your line of best fit. So I just wrote that down, I guess, already here. More words, but same idea. It's important to understand that because these both refer to y values, it is a vertical distance between your actual scatter plot point and the corresponding value that would be on the line of regression or the line of best fit. And so you can think of a residual as how far the data fall from your line of best fit or from your residual, or excuse me, from your regression line, too many R's. Sometimes this is called the observed error, but I will show you a picture here. So this is a very small example because it just has 5 data points. This is just, to get the idea. And so if you look at the first point, the value that is at x equals 1, the point that was on the scatter plot is this guy. And the point that is on the line of best fit is this guy. And so if you look at this, it looks like that scatter plot point was at 2, but the line of best fit is maybe at like 1.4. Okay, do I know that? No, I don't. I am estimating right here. Okay, and so if you look back at our definition, it said that we're going to take our scatter plot point minus our line of best fit value. So you could think of that as y minus y hat, if that helps you. Y hat are the values that are on the line of best fit. And so if we were to subtract 2 minus 1.4, that residual is 0.6-ish, right? I'm just kind of estimating here because we don't actually have the data. In the next location at 2, this point appears to be at like 2.1 maybe, and this is at 1. And so my residual there is approximately 1.1. Oh, no, I did that wrong. I'm going to leave it in the video, though, so you see the issue that I had. Okay, the issue that I had was I forgot the order, right? And so I need to take my scatter plot point minus my line of best fit point. So scatter plot point minus line of best fit point, that should be negative. Apologies. Okay, so if your scatter plot dot is too high, if their scatter plot point is above your line of best fit, you're going to end up with a positive residual. Whereas if your scatter plot point is too low relative to the line, then you're going to end up with a negative residual. Okay, and we can continue doing that throughout. Now, let's just cut to the chase on that. Okay, I just did some quick estimation without you. And so you can see that we'd have, these two locations, distance 2 and distance 4, those residuals would be negative, the other ones would be positive. And something else that you might notice is how there's a sense of balance. So the line of best fit is best because it manages to go right down Main Street. It goes right through the middle of our data in a way that the positive residuals and the negative residuals are balanced out. In fact, if you look at these residuals, add them up, what happens? Yeah, they should add up to balance out and come out to be 0 because you have positive and negative that are in balance with each other. So what we care about from this residual idea, like it's nice that the line of best fit balances, right? And it has like the error above and the error below kind of balance out. But what we are going to care about from that is we are going to make a graph that utilizes these residuals. In fact, it's going to use this exact chart. Right, so over here I have a chart that has the residuals listed and it also has my x values listed. And so instead of making a scatter plot of X versus Y, I could make a scatter plot of X versus residual. And that is called a residual plot. So a residual plot is designed to help us decide if our data actually has a linear relationship in the first place. We can have things that are related in a lot of different ways, right? You might have a graph that has time, and then on the other axis, let's take an example that has been in the news recently. So if you have time and then you have COVID infections, right? You could look at that relationship, and it's not actually trending like a line. It's trending more like a curve of some sort. So there can be a lot of different relationships between pairs of variables. They aren't all lines. And so a residual plot is to help you decide if your variables actually are related with a line. So it's going to be a graph of your X values versus the residuals. Okay, not X versus Y, but X versus residual. And the scoop is, if you see some sort of a pattern or shape in the residual plot, that means that your original data, your X and Y data, is not best related with a line. It's some other kind of relationship. So I have these pictures for you, and what you actually are quote unquote hoping to get is the first one. If you get in your residual plot a shape that looks like marbles on the floor, in other words, it looks like there isn't really a pattern, no pattern in a residual plot is a thing that tells you, hey, guess what? Your original data is linear. That lack of pattern is telling you that there's good scatter, right? We have some positive residuals on this part of the graph. We have some negative residuals on this part of the graph, and those don't all fall in just one part of the graph or another. They're kind of just mixed up arbitrarily, and that's good. Okay, now the other two patterns I have here are just basically flips of each other. And this would be saying, like, I have all my positive residuals at the ends, and I have all my negative residuals in the middle. That's not desirable because you don't want it to have a pattern. You want it to be like balanced. Remember that other picture that we looked at where it was kind of balanced, right? There was some above, some below, and not coming in any sort of order. That's what you're hoping for if you want if you're hoping for your data to be linear, okay? So maybe you're hoping for your data not to be linear. Then what I'm saying about hope doesn't make any sense. But the first picture is the picture of the residual plot that tells you, yes, your data is linear. If you have some other shape, like even if you had, say, like a trumpet shape is bad. Randomness is good, right? So if you had, like, here's my residual plot, things are kind of tight and then like bigger, 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 like that kind of shape, woo! That's what I mean by a trumpet, like flaring out. Or the flip of that, flaring out and then getting skinny, that also would be, no, your data is not linear, right? There's something else happening there, okay? Now, fortunately for you, this class isn't going to force you to find that other thing. We're just going to look at our residual plot and say, hey, it's linear, or hey, it's not linear. And if we say, hey, it's not linear, we should throw out our line of best fit and all of that because we just said it shouldn't, this data is not represented well with a line, okay? If we do get this kind of residual plot, then we say, oh, it looks like our data is related with a line very well. And we can go ahead and do our line of best fit and our correlation and all that, okay? So my idea here is for you to go back to the data from our previous lesson where we did the movies and you gave like 10 points to the movie you liked the most and then 9 and then 8, and then you had someone else do that. Now, if you don't have that data for whatever reason, in this next example, you can just use the data that I have, okay? And so it says here that you're going to go back to that movie data, you're going to write down the line of best fit, et cetera, okay? So let's just look at the calculator for a second. Okay, so, sorry, I was doodling around already. Okay, so this is the data that I am using. If you have different data that maybe makes this next part harder, I don't know. I do think it makes it more interesting because you're using your own information, and I feel like that's always more interesting. But if that makes you nervous, feel free to just utilize my example data, okay? So this is the data from our previous class, and this is the order I put numbers down for the movies that I listed, and then a friend of mine ranked those same movies. Okay, so this is the data that I used. You can pause and write it down if you need to use this data. Okay, and then in our last lesson, I'll just review how to do this. You go to Stat, Calc, item number 4 to do a line of best fit. I'm going to store my line of best fit as Y1. Okay, that all was in the last lesson. So there's the equation of my line of best fit. If you're using your own data, you will have different numbers here. That is okay. All right. And so here in my Y1 was the equation for the line of best fit automatically entered. Okay, that's where we were. Okay, so let's go back into our lesson. And there's a table like this that you should have for your notes. And you can see in navy blue, in that dark blue there, I just wrote down the data. Okay, so again, if you're using your own data, that's awesome. You'll have different data than I do, but you can find your data from the previous lesson in your list 1, list 2. I don't know why I couldn't draw a straight line there. That's really weird. Probably because I'm sitting on a bed doing this. It's not the most professional of looks here from your teacher. Okay, so this box, okay, that's what gave me this information. Okay, that's just from my previous lesson. And then I went on my calculator, and I'll do this with you, into table. And in table, you can see I have these different numbers that are on equation Y1. Well, what is Y1? Y1 is my line of best fit. So these are points that are on the line. These are not points on the scatter plot. Okay, the points on the scatter plot are these points back here, right? I rated the movie 1, my partner rated it a 2. I rated a movie 4, my partner rated it a 5, right? Those were the scatter plot points. But when I go into table, this clearly is messier than that, right? I rated a movie 1 and someone else rated it 1.9273. What? No, these are the points that are on the line of best fit. Okay, so the line of best fit went through my scatter plot, and these are the dots or the points that are on that line. Okay, so back here, I would take those values. I shouldn't say I would. I did take those values. I'm having such problems with the board. Oh. Okay, sorry. So you're going to take the numbers from that table and put them onto your chart. Now, you're not going to just read through. You have to match them up with the X value that they go with. So for instance, this X is 1. So here's the X that was 1, and I wrote down the Y from over here. This X was 4. So over here, I had to get this particular value, right? 4.309-ish. Okay, so I can't just like write them down in the order that they come because these X's are not in that same order. They're not 1 through 10 in order. Okay, now once you have all of that, then we have to think about how we define a residual. And a residual is the Y coordinate minus the Y coordinate of the scatter plot minus the Y coordinate on the line. So if I were to subtract 2 minus 1.927, that's going to be the residual that I put in that slot because that's like how far off my line is relative to my scatter plot. In this case, that would be 0.073 would be my residual. I do the same thing here. I'm subtracting 5 minus 4.309, 8 minus that, 9 minus that, 7 minus that, etc., all the way down. Okay, so through a little movie magic, you do all those subtractions, okay? Now, what's interesting here is what I mentioned in that simpler example earlier. Your residuals should add up to 0. Now, it won't be perfectly 0 here because we did do some rounding, right? We rounded things off. So if I added this up and I got like 0.001, I would not be flummoxed, right? That's fine. That's 0-ish. It's close enough. And if I had more decimal places of accuracy, I would have actual 0, okay? So the calculator is going to find the line such that the sum of the residuals is 0. Now, there is another column on this table, and I just want to mention this just as sort of a side note. What the calculator actually does in finding your line of best fit is not so much look at the residuals and find the line that makes the residuals be 0. What it does is it takes all of those residuals, it squares them all, and then it finds the line such that the sum of the squared residuals is as small as possible. So that is why the line of best fit is formally called the ordinary least squares line. Okay, it is making the least or the smallest amount in the squares of the residuals. That is really extra that, you know, I'm mentioning this just because I'm a math nerd. All right, so hopefully at some point in all of this you thought, gosh, I hope there's an easier way. Because guess what? There is. You get to use technology, which is fantastic. Okay, so if you want to make a residual plot on your calculator, some of these steps are basically just stuff we did last lesson. Put your data in, list 1, list 2. Find the line of best fit. You have to find that because you can't have a residual plot or you can't have residuals even without having a line, right? The residual is the distance between the scatter plot points and the line. Sometimes people don't do this step and they're like, why can't I find a residual plot? I don't know what your line is yet. Okay, then this part, I'll just show you this. Okay, that's easier. Okay, so variables y1, that's actually part of this linear regression. Okay, this last bit we haven't done. Okay, so in the calculator's brain still is the line of best fit from before. Just in case, if you think like, maybe the calculator forgot or you're not sure if you did a line of best fit, you can always do it again. It's not going to hurt anything. Right, come down here, right here, go back into variables, y variables, pick y1, ta-da, here we are. Okay, so the elves in the calculator are thinking now about your line of best fit. Now go back where your data is in stat. And then right over here where it's L3, you're going to scooch up to the top of L3, and then you're going to go into list. Where is list, you ask? Well, it's on the same key as stat. So it's second and then list. And look at that. How about it? Resid. Seems like something that might mean residuals. So pick that, hit enter, and there's all those stinky values that we were just trying to find with more decimal places of accuracy. That's fantastic. Yay us. Okay, so now think about what a residual plot is. Residual plot is x values versus residuals. So go into stat plot and say, hey, I would like to make a scatter plot of x values, which live in list 1, versus residuals, which live in list 3. Now, how did I get that? The second key and then the number 3, okay? Okay, once you have the L3, then you're going to do zoom statistics, like per usual. Oops, I forgot to turn off the line there. Okay, so my bad. I still have my line of best fit floating through here. We could turn that off. I'll show you how to turn that off. So in y equals, I just want that equal sign to be off. Right? And now it won't graph. All right, so here's my residual plot. It actually looks pretty good. I don't really feel like that's pattern-y, right? It doesn't show like an arc. It doesn't show a trumpet. It shows pretty good scatter. I have some above, some below. Okay, it's not really exactly equally balanced, so it's not like perfect, but I would say my data is pretty linear. So that's exciting for me. I know that now. I know I can proceed and use a line of best fit if I wanted to describe my movie data. All right, the last couple little things are sort of like loose ends, so to speak. So we've talked about outliers previously. We talked about it relative to single variable data. And so an outlier, you know, is something that just doesn't fit the general pattern of the rest of the values in a data set. And so, for example, if you had the variable of age and the sample is everyone in stats class, and you had one retired person who is somehow in your data set, that person would be an outlier because they're not really falling within the typical scope of where the rest of your data is packed together. And the key idea here that I think is sort of interesting to think about is depending on where an outlier falls, your R value, your correlation coefficient, can either be increased or decreased. It just depends. You have to kind of look, okay? So if this is the pack of data that you have, all of these red dots that are all together, and then your line of best fit is that red line, and then your outlier is that blue dot, well, that blue dot is fitting the trend. So even though there's like space between that point and the rest of the data, it still fits the trend line. Okay, so that point, although an outlier, is going to actually improve your correlation, right? It's like making your correlation stronger because there's yet another data point that fits your trend. Whereas if I have this pack of data here and my trend line, this point is again an outlier because it's this big pack of space. It's not really fitting the rest of my data, but it's not helping with the correlation. It's probably pulling where this line is, probably pulling it down a little bit toward itself, right, towards this. So how do I know which kind I have, right? This is the kind of outlier that is making my correlation weaker, whereas this is the kind of point that makes my correlation stronger. I would say anytime you're not sure, you could just delete that point from your data set and then find the correlation again and see, right? Does that point have a lot of influence? And so this is in fact called an influential point when you have a point that is pulling your line of best fit in a different direction than it otherwise would be. This is not really impacting where the line is. The line is where the line is, and it's not really changing anything. So when we have an influential point, we sometimes will report, you know, this is my data set. It has, you know, 100 points in it. It would have had 101 points, but there was an outlier that I chose to remove because it didn't fit the general trend. And I wanted to just look at the general trend. Okay, you should report that. You don't like try to hide things, right? That's not ethical. But if you have something that's just like, oh, this is just one point that isn't fitting, you can choose in a study to say, I'm not including that point. It doesn't fit the general pattern. Okay, one other loose end has to do with these two terms, interpolation and extrapolation. We find the line of best fit because we'd like to be able to use it to predict things, okay? And there's two kinds of predictions that you can make, interpolation and extrapolation. So if I had a line of best fit that was like this, and I wanted to know, using my line of best fit, I'm like, hey, I want to know about what happened in June of 2009, right, halfway through that year. Then I would look here, I'd look at my line of best fit, I would find that point, I'd look over to this side, it would have some numbers on it, and that would be my prediction, okay? That's what's called interpolation, because I had some data that was here, and I was picking a point within the span of the data. However, if I'm using my line of best fit, which in this case goes from 2008 to 2010, if I'm using that span of data and I'm trying to predict something in the future or something in the past outside of that data set, that's extrapolation. So interpolation is when I am making a prediction inside the given data. Extrapolation is when I'm predicting outside the given data. Which one is kind of risky? Extrapolation is more risky, okay? If I were to take your data of your height and weight from the first 2 years of your life, I would predict that at your current age, you would be 18 feet tall. Why would I predict that? Well, because you doubled like your height and your weight a few times over the course of the first couple of years of your life, right? You got to be huge. You were born at like 20 inches tall, 20 inches, not even 2 feet. And then you like got to be twice as tall, right? Like that's amazing, right? Over the first few years of your life. So we don't keep doubling our height though. Right? So extrapolation is a little dangerous because it assumes that the same pattern or relationship continues, and it might not. The pattern might change. Interpolation, because you have data before and after the point at which you're making the prediction, is a little bit safer, just in terms of your correctness. Okay? In problem set 2.2, I'd like you to do these 5 problems. You're welcome to do more, of course, but at least those. Thank you so much.